Hello, everyone. Welcome back to Vergara's Adventure. Today, we are diving into the fascinating world of the states of matter. Whether you're a student studying science or just curious about the world around you, understanding the different states of matter is crucial. So, let's jump right in. What are the states of matter? First things first. What exactly are the states of matter? Matter exists in three primary states: solids, liquids, and gases. Each state has its own unique properties and behaviors. Anything that has mass is made up of matter, an all-encompassing word for atoms and molecules that make up our physical world. Most people are familiar with three states of matter: solids, liquids, and gases. Let's break them down one by one. Solids. Solids are characterized by a definite shape and volume. The particles in a solid are closely packed together and vibrate in place. The forces between particles are strong so that the particles cannot move freely but can only vibrate. As a result, a solid has a stable, definite shape and a definite volume. Solids can only change their shape by force, as when broken or cut. This arrangement gives solids their stability and rigidity. Common examples of solids include ice, rocks, and even the desk you might be sitting at right now. Liquids. Moving on to liquids, they have a definite volume but take the shape of their container. The particles in a liquid are more loosely packed than in a solid, allowing them to flow and move past each other, giving the liquid an indefinite shape. Therefore, the liquid will conform to the shape of its container. Water, oil, and even your morning cup of coffee are examples of liquids. Gases now. Gases are quite different. They have neither a definite shape nor a definite volume. Gas particles are spaced far apart and move freely, filling the entire space available to them. If unconfined, the particles of a gas will spread out indefinitely. If confined, the gas will expand to fill its container. When a gas is put under pressure by reducing the volume of the container, the space between particles is reduced and the gas is compressed. Examples of gases include the air we breathe and the helium in a balloon. Changes in states of matter. It's not just about the three main states. Matter can also undergo changes between these states. This process is known as phase changes, and it happens under different conditions. Let's explore these changes. Melting and freezing. When a solid turns into a liquid, we call it melting. If you took out the ice cubes from the freezer and placed them in a warm room, the ice would absorb energy from the warmer air around them. This absorbed energy would facilitate them to overcome the force of attraction holding them together, enabling them to slip out of the fixed position that they held as ice. The melting point is the temperature at which a solid changes to a liquid. On the flip side, when a liquid turns into a solid, it's called freezing. Heat transfer occurs between the warmer tray and the colder air in the freezer. The warm water loses heat to the cold air in the freezer. This heat transfer occurs until no energy is available for the particles to slide past each other. This forces them to remain in fixed positions, locked in place by the force of attraction between them. This way, liquid water is changed into solid ice. The temperature at which it occurs is known as a freezing point. Vaporization and condensation. Vaporization is the process of turning a liquid into a gas, and condensation is the reverse, where a gas turns back into a liquid. If the water is hot enough, it starts to boil. Bubbles of water vapor are formed in the boiling water. This happens as particles of liquid water gain enough energy. to completely overcome the force of attraction between them and change to the gaseous state. The bubbles rise through the water and escape from the pot as steam. The temperature at which a liquid boils is its boiling point. Boiling and evaporation are common examples of vaporization, while dew forming on a cold surface is an example of condensation. When you take a hot shower in a closed bathroom, the mirror is likely to fog up. You may wonder, why does this happen? Some hot water from the shower evaporates, and when it comes in contact with cooler surfaces such as a mirror, it cools and loses energy. The cooler water particles no longer have the energy to overcome the forces of attraction between them. They come together and form droplets of liquid water. Sublimation and deposition. Lastly, there's sublimation, where a substance transitions directly from a solid to a gas without passing through the liquid state. This occurs when solids absorb enough energy to completely overcome the forces of attraction between them. Dry ice is an example of solids that undergo sublimation. The reverse of sublimation is deposition, where a gas transforms directly into a solid. The gaseous substance gets deposited usually as crystals bypassing the intermediate liquid state. An example of deposition is when water vapor in the atmosphere changes directly into ice, such as the formation of frost. And there you have it, a brief journey into the world of the states of matter. From solids to liquids and gases, with intriguing phase changes in between. Understanding these concepts is essential for grasping the fundamental nature of the physical world. If you found this video helpful, don't forget to give it a thumbs up, subscribe for more science content, and let me know in the comments what topics you like to explore next. Until next time, stay curious.